Perfect. Hello from me too. Today I will present to you the project that we create in collaboration with Big Blue Data Academy and Infrared City. The project involves the development of an AI interface that uses open geospatial data for the generation of reports and insights using language models, helping policymakers make data-driven decisions. I am Efika Nicolaou, a geospatial data engineer with a master in geoinformatics, and now expanding my career into data science, I would like to combine machine learning methods with geospatial intelligence. A quick view in the table of contents. Today, we will see some of the geospatial challenges we face in urban development, how we can make those data accessible to the stakeholders. We will analyze the data, the methodology that we follow in order to implement an interactive platform using Streamlit, and have also a live demo. In the end, we will see some conclusions and further steps for the project. So, Infrared City is a company based in Vienna. It offers real-time environmental simulation services powered by artificial intelligence, analyzing parameters such as wind and solar radiation. The simulations are really fast and high accurate. Now let's see the challenges we face when we use geospatial data. First of all, we have access to billions of satellite pixels, but unfortunately, they remain inaccessible to the most of the users. This data usually requires expertise in remote sensing, GIS, and coding, and creates a gap where many policymakers find it difficult to have insights directly from the data. Finally, we must consider that static dashboards cannot answer dynamic questions. So, in order to change this gap, let's see how we can extract useful insights just with questions. Geo RAG stands for Geospatial Retrieval-Augmented Generation, and it is a tool designed to analyze satellite images and geospatial data efficiently. The key feature is the development of the models that can answer natural language queries. So imagine asking a question like, can you make an environmental analysis near my point of interest and give me the vegetated areas around the point? And the response to be spatially and temporally filtered. This capability will allow urban planners to make informed decisions based on real-time data. Next, we will discuss in more detail the data sources that we used. The data sources that we used was both raster and vector data. Firstly, using Sentinel-2 and Sentinel-3 from Copernicus data space ecosystem, we calculate for 12 months various environmental metrics like NDVI and moisture from vegetation, building indices, surface reflectance, and we downscale the surface temperature into Sentinel-2 resolution. Furthermore, we integrate data from OpenStreetMap API, retrieving tags for land use, materials, and building types. This helps us to enhance our model embeddings, creating a robust retrieval-augmented generation process. So, in short, let's see the workflow of the technology stack. Firstly, we call the APIs to calculate the environmental metrics and clip the vector data into the bounding box of the area of interest. Following ELT processes, we load the data in the Postgres database that has a spatial extension to manage geometries, and combining those data that we create pixel-based summarizations of the metrics and embed them into a QDRAN vector database. Using a LangChain framework that connects the vector database for a smart search with LLM models for a smart answer, we have the geospatial retrieval-augmented generation. So, visualizing the semantic responses on map, lead us to the environmental report generation, making useful insights for policymakers and planners. So the key point is to move from satellite data to insights. So let's have a small demo of our application. So here is the application of AI engine for urban and environmental insights. The user can interactive react with the map and create a bounding box, or even enter manually coordinates, defining the bounding box size. So let me press here. A bounding box is created, so we can move directly to metric visualizations. We go to the tab for metric visualizations. Here is the first site of the data that was retrieved from the two satellites and the OpenStreetMap. So the user can navigate through the months of 1 year. For example, let's see for July, the urban index, and refresh the data. For demonstrated purposes, we cut down some the area into a radius. So here the user can press and see the metrics. Let's go on to the AI agent, this powerful tool. Here the user can ask questions like, can you find me schools? It's a really easy question. Now it's searching the vector database for similarities depending on the school amenities, and the response will be a content and also a visualization to the map. So we enter that in location with this pixel ID, this coordinates, all the pixel that founds school amenities, find summaries of the findings, environmental implication and recommendation, and you can see a visual representation of a map. So you can enter the map and press into the pixel size and see that here is all a school. So let's go on in more spatial questions, like analyze the indexes of this point of interest within 150 meters radius, and show me chart for the characteristics. So we have both context, we receive context of the environmental analysis, and also some plots that can indicate the metrics, and changing the basement. Here was the school, so defining the radius of the point of interest, we calculate into 150 meters radius the metrics. So let's see a more robust question about the AI agent can adapt to users' needs and can provide also answers in English and in Greek in order to be more user-friendly experience. So we receive the results in Greek, also the map for visualization scopes. Let's change tab and go to the heat map analysis and have an advanced environmental analysis, like searching for urban heat islands during the summer months and explain their characteristics. The user can define the text analysis similarities, the limitation of the text analysis, and also the limit of the visualization output. So here we can see conclusion, environmental implication, and some suggested interventions about the urban environment, and see where is the urban heat islands near the roads, and on the other side we can check how the cool islands uh, are plotting in the map. So here is the cool islands determined with the pixel IDs and locations, also the metrics and in the indicator number. And here we can see that obviously near the river or in the backyards of the building blocks are cooling islands. So let's move to the presentation. So the concept of chat to map is our approach to give direct insights into policymakers or environmental scientists without technical expertise by natural language, maps, and plots. I can ask questions to get visual answers, get environmental analysis, and through an AI generator can make environmental interpretations. In some further steps, we would like to fit our model globally and have parallel processing in order to fit across regions and cities. We would like to integrate machine learning techniques, train models in order to detect urban features, and last but not least, policy-aware intelligence, where we will use strategies and climate policy documentation in order to build a more robust application using all data and policy context. Thank you for your attention. I'm here for questions.
Effie, thank you. Thank you for the great presentation and the amazing demo and all the hard work you put in the last 6 weeks. Do we have any questions from the audience? By the way, you can write your question, or you can actually request for microphone, so you can participate in the event. I have one question for you, Effie. What was the most challenging part all over in this
The
project?
most challenging part was how big was the spatial data, because their size, it's really the computation time to extract the data and process in the pipelines took a lot of time in order to give results.
We have a question from Angelos Chronis.
Hi, I don't.
Hi. Oh, so it's actually interrupted. Yeah. Coming back to you. Okay.
Hi, I don't know if you can hear
Hi,
me.
Angelos.
Yeah,
Yes.
it's a bit difficult with the platform. Hi, everyone. It's more sort of like a comment than a question. I just want to say I want to congratulate Effie for the work, and I do think that this is sort of like really groundbreaking work, because we are actually sort of like almost ready to have that in production. So I think, you know, the work is really sort of like stellar, and definitely touched on a subject that we've been thinking for a while. And we're quite impressed by the amount of work that was done within 6 weeks. So congratulations to Effie and to Dimitris and everybody in Big Blue Academy, because this was really, really great work. Yeah.
Thank you, Agelos, for your support and everything.
Angelos, thank you so much.
Cheers.
Do we have any other questions? Okay, before moving to the next one, I would also like to thank Angelos Chronis that actually give us the opportunity to collaborate on this project, and also for the help from Infrared CDU side. I would like to thank Oana Taut and Vaya Pragya. And of course, Effie, thank you once again for the splendid work you've done.
Thank you. Thank you a lot for your support.